Hello everyone. In this video, I'm going to explain about cooling towers and ponds in thermal power plant. In that first one is natural drought cooling, wet type. Here, a condenser is will be here, and the water pond. And from the water pond, the water is pumped to cooling water through the cooling water pump to the condenser, and there once the steam will be condensed, but cooling water will be it will absorb the heat from the steam and it will become hot water, and that water is pumped to the uh, like the through the tubes to the cooling tower. At the top of the cooling tower, there it is water spray will be there. So just like a rain, so it will come down. It will be coming down like this in droplets, in the form of droplets from here, and this whole thing is cooling water, cooling tower. Sorry, and here there will be a gap between the water level and the cooling tower. Can say the basement, so that in through the basement, the because this will be at a higher temperature. This reason, because hot water will be coming down like this, so the low pressure region will be created because of that density. So to cover that, to fill that space, this will be coming the whatever cold air surrounding to this will be coming into the cooling tower, and it will be moving towards, because as it absorbs heat, its density will be lower, and it will be floating in the upward direction. So that's why, because there is no external source is used to force the air towards the top of the cooling tower, so there it is happening. This whole thing is by natural, so that's why it's called as natural drought. The airflow, natural airflow from bottom of the tower to the top, because of density difference. As the cold air is moving upwards, the hot water will be coming downwards in the form of droplets. It will absorb that heat from the droplets. Water particles, molecules will absorb the heat from the droplets, and it will move upwards, and it will be moving out of the cooling tower. Around 20% of the water, it will be moving out of the cooling tower in the form of steam, or yes, in the form of steam, or you can say just like a fog, the moisture. So once, okay, that while coming down, that will be cooled. The water is now the temperature is reduced, and when it touches this, when it comes back to the water pond, it will be at normal temperature. And it is a direct type. It's wet type. They are saying wet type because direct type heat exchanger it is. Both the fluids are uh, directly come in contact with each other for the exchange of heat, so that's why it's called as direct type, or wet type, or a mixed type uh, heat exchanger, or you can say here the heat exchanging is taking place. And this is the whole thing is happening by naturally, so that's why it's called as natural drought system. So cooling from the water from cold water from pond to the condenser, and once it absorbs the heat from there, it will come to the it is forced, it is pumped to the top of the cooling tower, the spray, and the droplets come in contact with cold air which is moving upwards, and it is the all the heat is absorbed by the cooling air, become hot, and it will move up to the at the atmosphere, and this cold water will come to the water pond. Second is a forced drought cooling tower. This is also wet type. So for why it's forced draft, you can observe the difference here. The forced uh, draft fan is used here, like it will just suck the air from the atmosphere and it will force it towards the top. So that's why it is made in this way. The cold water is pumped to the condenser through the water pump, and that is just same thing is it will force that through the condenser to this top of the chimney, and from there there will be sprinkling, or you can say the water will be sprayed. And so here the difference is, one is forced draft fan is used, the other thing is baffles. So in between there will be baffles. So for a good or you can say efficient heat transfer, the air is forced like this. It will be and the hot water is coming down. This hot water will come in contact with this baffles. So the heat is absorbed by the baffles also. And as moving, the air is moving upwards, it will absorb the heat from the baffles also with the water droplet. And here also there is a direct contact with each other. I mean, both will mix it and then there will be heat exchange takes place. So that's why it's called as wet type. And once the hot water droplets give all the heat to the air and baffle, it comes down to the pond, come back to the pond and at the normal temperature. So then the same cycle repeats. Third one is in induced draft, a drought cooling system. Because why it's used, you just observe here. The forced drought, here there were for FD fan, and here this is induced drought fan. So at the top, so the same thing, the cold water from the pond is pumped to the condenser, and that is forced to the top of the chimney, so that there will be a water spray. It will be sprayed to downwards, and it will be coming down in the form of droplets, hot water, and the baffle plates same for maximum heat transfer, to ensure the maximum heat transfer. And the droplets will be passing through the baffles also, where it will take absorb the heat, and also through the water, the air will absorb the heat from the water droplets, and which is moving upwards, and also from baffles, it will absorb, the air will absorb the heat, and it will be taken away from here. So that will be the suction of air is taking place by an induced fan, which is at the top. So that's why it is called as induced drought cooling. So there is also, this is also wet type, as there is a mixing of both the fluids takes place. Direct cooling tower, dry type. So here, direct cooling tower. So this is like steam from the exhaust of turbine. It is stored here. Then from both the side, the tube is there. Here there is a tube. Through that it will be passed, and it will direct. I mean, continuous flow will be there through the tube, and surrounding to that tube, they are using fins, the condenser tube with fins. So here the fins are used to increase the heat transfer rate, because if you use the fin, it will increase the surface area, and once you increase the surface area, there will be more heat transfer. So uh, as the surface area increases, there will be more heat transfer. Heat transfer also increases. So in the heat transfer rate increases. So that is the main reason they are using fins. And here, what they will do is they will use a forced draught fan, which will force the air from this condenser with fins, and that will, the maximum amount of heat is taken away from this. And once it is done, so directly the cooling takes place in the condenser itself. There is no again the uh, thing will come, it will go to the cooling tower again, like that. So same, all the things is happening in this way. And once it is condensed, the steam is condensed, then the that condensed water is taken to the is pumped back to the boiler or feed water line through the condenser pump. From here, condensate pump, you can see here, which is, this is the, so from here the steam comes, and once it reaches here, that will be condensed at this point, and that is collected in one receiver, and then it is pumped to the boiler again with the as a feed water. So this is the direct cooling, dry type. And indirect cooling. Why they are called as indirect cooling is like separate condenser will be there, and steam is coming here, and steam comes from here, and it is condensed, and it is fed to the boiler. So this is one cycle. So like this, from the boiler it comes, from the turbine it comes condensed, steam condensed, and it will be converted to water, and that water is fed to the boiler. So this is taking place here. So it is not taking place at this point. It is taking place, it is act as another system, so it is not direct type. But whatever cooling water we are using there is like once it so cooling water to the condenser, it absorbs that heat from the steam and become hot water. It is supplied here, and that will be passing through the uh, condenser tube with the fins. So there we are using here we are using induced fans here at this point, which will draw the air from this. So it will draw the air from this system. So like that, there will be cooling of water takes place. Then that cooled water is stored in one cooled water tank that will be pumped to the condenser for the condensation purpose. So there is no direct involvement of steam here, so directly steam is not involved. Only to condense that steam, it is water is used, and that hot water is cooled by this system. So that's why it's called as indirect dry cooling. So there is dry because there is no mixing direct mixing of two fluids, and that heat transfer is not taking place by mixing. It is just indirectly. One fluid will be flowing inside the tube and other fluid flowing outside the tube. So like that it will be. So indirect dry cooling tower with the open type condenser. So here you just see that same, the last is there, last indirect type dry cooling. But the difference is, instead of condenser, the normal tube and shell type conductor, they are using a spray type condenser where there is a directly it will be come in contact, the steam comes in contact with water. So how they are cooling is, you just please observe here. Steam comes from the turbine, and it will be passing like this. On the steam, this air is sprayed like this. The air sprinkler will be there, and because of that cold water contact, it will be condensed at this point. It will be condensed, and it will come here. So part of the water will be fed to the boiler, and that part of the water will be taken to the hot water is taken to the condenser here. For so in this condenser, sorry, in this system, cooling tower, think here two condenser tubes will be there with fins for maximum heat transfer. And when it is passing through, the induced fans will draw the air from this side. So that air movement will uh, so that air will absorb the heat and passing through the induced draft fans, and because of that, the heat transfer, it will get cooled. That hot water will get cooled, and it is collected in the cooled water tank, and that same cold water is pumped back to the direct type heat exchanger where it is sprayed. Again the same thing, the condensed will be some amount of water is go to the feed water, and the hot water will go to the hot water sorry, the cooling tower. So this is in this way it works. So that's all, thank you.